Hello everybody, this is Mr. Dowse. Today's lesson is going to be over multiplying polynomials. I'm going to show you two different methods. One is called the box method, the other one is called the FOIL method. There are other ways of multiplying polynomials, but these are the two ways that I prefer. So first of all, let's talk about what a polynomial is. A polynomial is an expression with one or more term. So when I say term, like this is a monomial, this is one term, 2x squared. Binomial, we're going to have two terms. So that would be like this is x is one term, and then -6 is a second term. Then a trinomial would have three terms, and I'm just going to underline the three terms here. So notice basically the terms are separated by plus signs or minus signs. And so these are examples of polynomials. So today we're going to multiply, for the most part, a binomial by a binomial. But I think there's at least one example where it's a monomial times a binomial or a binomial times a trinomial. And the steps are similar, just if there's more terms, there's just a little bit more math to do. So there are two steps that need to be done to multiply polynomials. The first one is to distribute, and the second one is to combine like terms. So when I say distribute, you're going to end up multiplying what's outside the parentheses into the parentheses here. And so as an example, and this is a little bit tricky example, I don't think I've done a problem this hard in this class, but if I had x squared, this is going to be like x squared times -2xy, and this is going to also be an x squared times 3x squared y. So the idea is I'm going to multiply this term into each of these terms. And so when I have x squared, this is like a 1 in front, 1x squared times -2xy, you multiply the coefficients together, -2, and then you multiply the variables together. And notice I have an x squared times an x. There's a total of 3 x's here, so that'd be x to the third. And then there's only one y here, so I'm only going to have one y here. So remember, whenever you multiply exponents, you actually add the exponents together. So there's a 1 implied next to this x, so 2 plus 1 is 3. And then there's no y here, that'd be like y to the 0. And this is y to the 1, so 0 plus 1 gives me just 1y. And then same idea is going to happen over here. There's a 1 implied in front of this x squared, so this is 1 times 3, so you multiply the coefficients together, and then you multiply the variables with the same variable together. But when you multiply these two, you actually add the exponents, so 2 times 2 is actually going to be 2 plus 1, so it's x to the fourth. And then there's just one y, so there's only one y. So this is possibly, this is, I think, one of the harder examples I've done when it comes to distribution. But the idea is whenever you're multiplying exponents, you actually end up adding them. And then combining like terms. So notice here, these two are like terms because they both have one x and one y. And then this 8x squared and -3x squared, these are like terms because these both have terms that have an x squared in there. So when I combine like terms, my 2xy minus 3xy is just 1xy, or minus 1xy. And then my 8x squared minus 3x squared is a plus 5x squared. In reality, I don't need this 1, so this can simplify down to -xy plus 5x squared. So these are the steps that we're going to end up doing in these problems. We're going to distribute, and then we're going to end up combining like terms, and that's the gist of how you do the two steps that we're going to do when we multiply two polynomials. So using the box method, you might have heard of this as called the Punnet Square in biology when you're dealing with genetics. But the idea is you make a little box, and there are two terms here and two terms here, so I need a box with 2 rows and 2 columns. So on the left here, I'm going to write down these two terms, so 5x and a plus 2. And over here, I write down these two terms, -3x minus 4. So you need to keep these terms together. So I could put these terms here or put these terms on top, but they need to stay together. And then this -3x minus 4, again, I could have put them on these two spaces or these two spaces, but the idea is they need to be grouped together. And whenever we do the box method, we actually multiply the row by the column. So like 5x times -3x, you multiply the coefficients to get -15, and then you add the exponents. So this is a 1 and a 1. They're a total of 2 x's. Then I'm going to multiply this row by this column. So 5 times -4 is -20. x times, well, this is like x to the 0, so there's only one x here, so that's just x. Same idea here, multiply this row by this column, so 2 times negative 3 is negative 6. There's only one x here, so I'm going to have one x. And then multiply this row by this column, so that is 2 times negative 4, or negative 8. So that is the distribution. So whenever we're doing this, we're multiplying, and we're actually, it's the idea of we're distributing. And then so now the goal is just to write what is inside these boxes in one line, and then you just combine like terms. And in general, you're going to multiply these guys that are diagonal of each other. Notice how they each have a term of x. So I can't combine the negative 15x squared with anything because there's no other x squared term. But I can combine the negative 20x minus 6x, get negative 26x, and then I can multiply this constant here. And this is how you multiply two binomials. When you multiply two binomials, you generally end up with a trinomial. So same idea for number 2. So I'm going to do a couple of these. So I'm drawing a 2 by 2 box because I have 2 terms here and 2 terms here. So I need 2 rows and 2 columns. So I'm going to do my n plus 3, my n minus 3. We're going to multiply these 2 rows and columns together and get n squared because I have a total of 2 n's. N times negative 3 is negative 3n. 3 times n is 3n. And then 3 times negative 3 is negative 9. And then I'm going to write all these terms down in one line here. And then I just combine like terms. And notice how these like terms here actually cancel each other out. So you end up with n squared minus 9. So let's do a couple more examples here. Let's look at number 3. Now this is 2x plus 5 squared. That's the same thing as 2x plus 5 times itself. So if this was a 3, I'd have another one of these here. So I'm going to multiply this by itself twice. So a lot of people think this would be like 4x squared plus 25. You're just going to square everything, but that's not right. Can you multiply whatever's in the parentheses by itself this many times? So from here, hopefully you're getting the idea of what happens. So I'm going to put a 2x and a plus 5, 2x and a plus 5. When I cross multiply, I get 4x squared. 2x times 5 is 10x. 5 times 2x is 10x. 5 times 5 is 25. I'm going to write all these out. So 4x squared plus 10x plus 10x plus 25. And again, notice diagonally here, these are like terms. So if you want to skip this term, you could. You could just do 4x squared. You know that this adds up to 20x. And then we have the plus 25. And then let's do this last one here, number 4. This is a trinomial times a binomial. Again, so this is a 3 by 2, so 3 terms by 2 terms. So I'm going to have 3 rows. Sorry, yeah. No, sorry. I'm doing this backwards. I'm going to have 3 columns here. So I'm going to put actually the trinomial on top here. And then x plus 6. And the idea is, it doesn't really matter where you put each one of these. So I could have put 3. Let me move up. I could have put 3 rows, and I could have put x squared plus 3x minus 2, and I could have put an x plus 6 here. But the reason why I set it this way, where I have 3 columns and 2 rows, is because notice how it just fits better on the page. The whole goal is to try to save space here. So again, but you could have multiplied it like this, and you'd still get the same answer. But I don't set it up like that because my goal is to save paper, and it makes more sense to me to go horizontally here than for it to go vertical. But the idea is going to be the same here. I'm going to multiply this row by this column, and notice there's 1, 2, 3. There are 3 x's. X times 3x, so this is a 1 in front. 1 times 3 is 3. There's an x times an x. That's a total of 2 x's. And then 1 times negative 2 is negative 2. There's only one x between these two, so I put 1x. And then 6 times x squared. Again, there's a 1 here, so 6 times 1 is 6. There's a total of 2 x's here. And then 6 times 3 is 18. There's a total of only 1 x between these two terms, so I'm going to put 1x here. 6 times negative 2 is negative 12. And then you notice here how diagonally these terms are matching up. So I'm going to write all these terms out. lengthwise right next to each other and combine like terms. And then we'll be done with this problem. So there's no term that has an x to the third here, so that stays by itself. But I can combine this plus 3x squared with a plus 6x squared, get 9x squared. Then I have this negative 2x plus 18x, so that adds up to being 16x. And then I have this one constant here, which is negative 12. And so when I did this trinomial by this binomial, I ended up with a 4-term polynomial. And then I'm not going to do number 5. And I'm going to move on to the FOIL method. So the FOIL method is, it's a little different. The box method is very visual in that you actually draw a box to help you multiply. But when it comes to the FOIL method, FOIL is an acronym. FOIL, the F stands for first, where you multiply the first terms together. And then outside, or the O is for outside, where you multiply the outside terms together. And then inside, you multiply the 2 inner terms together. And then the L for last is you multiply the last 2 terms together. And you end up with 1, 2, 3, 4 different terms. Just like what we did over here, where we ended up with 4 different terms. But you skip over this whole box here, and you just kind of multiply each term in an organized fashion. In reality, what you're doing here is you're multiplying the first term by the first term by the second term. And then you take the second term, multiply it by the first term, second term multiplied by the second term. So each term on the left polynomial is being multiplied by each term on the right polynomial. So you end up with 4 different terms there. So if I multiply the first term by the first term, that's 2a times 7a. Then I multiply the first term by the second term on the second part of the polynomial over here, and I get 2a times 3. Now we're going to move on to the second term here times the first term, so negative 1 times 7a, and then the second term by the second term, negative 1 times 3. And keep in mind here, the signs that I'm writing down here are the signs of the first term, so or in the first polynomial. So this is a positive 2a because this is a positive 2a. This is a positive 2a, positive because this is positive, but this goes negative because this is negative. This goes negative because this goes negative. If this was a negative value, this would have been negative as well. So the signs in here, where I'm going to end up combining like terms and adding and subtracting, are all dictated by the terms in the first polynomial. So if I multiply 2 times 7, I get 14. A times a, there's 2 a's here, I get 2. Plus 2 times 3 is 6. There's only 1 a here, so I have 1 a. Negative 1 times 7 is negative 7. There's only 1 a here, though, so I have just 1 a. Negative 1 times 3, negative 3. And again, combining like terms, the middle 2 terms are going to combine. The outer 2 terms are not. So 6a minus 7a is a negative 1a, or just negative a. And then I have a negative 3. So that's the idea. I prefer the FOIL method. I call it double distribute as well, because you're just double distributing. Because it's a little faster and it requires less work, in my opinion. In reality, I'm not going to do this step on any more of these. So in my opinion, these are a little quicker because there's only 2 steps. Versus on the box method, you've got to write down this step, and then this step, and this step. So again, it's whatever. Most of my students prefer the box method because it's visual. But I prefer the FOIL method just because it's a little bit quicker. So anyway, over here I'm going to multiply the first term by the first term, and I get x squared. First term by the second term, get negative 3x. Second term by the first term, get plus 3x. And then the last term by the last term, I get negative 9. And if I combine like terms here, you notice that these are opposites, so they cancel out. So x squared minus 9 is my answer. Moving on to another example here. So I have 2x minus 1 squared. Hopefully remember from the previous example, a few examples ago, that this is actually going to be 2x squared minus 1 times itself. And so now, when I do first times first, it's going to be 2x times 2x, that's 4x squared. I do the outside ones, or the first term times the second term, that's 2x times negative 1, which is negative 2x. I do the inner 2 terms, or the second term times the first term, you get another negative 2x. And then you do the last 2 terms, or the second term times the second term, you get a positive 1. And again, combining like terms, these two are like terms. So I get a negative 4x plus 1, and that is my answer on number 10. Now number 11, let's do 11. First thing I need to do on number 11 is notice that there is a 3 here, and then I've got a polynomial times a polynomial. So the idea is I'm going to distribute the 3 into the parentheses first, and I end up with a 6x minus 9. And then I'm going to multiply all that by 4x minus 6. So the goal is I want to combine these two before I do anything else. So now I'm going to do the FOIL method, or double distribute. So I'm going to do 6x times 4x. That's the first two terms, 24x squared. The outside terms, 6x times negative 6 is negative 36x. The inner two terms, negative 9 times 4x is negative 36x. And then negative 9 times negative 6, the last two terms, it's a positive 54. Combine like terms here, I have 4x squared minus 72x plus 54. And that is the answer on number 11. And finally, number 12. And that's my last example here. So, so the FOIL method doesn't quite work on this because this is a trinomial. I can't do first, outside, inside, last because there's an additional term here. So this is where I like to call this a double distribute, where I'm going to distribute the first term into all three terms, and then I'm going to distribute again the second term into all three terms. So the idea is x times 2x squared gives me 2x cubed. X times x gives me a plus x squared. X times 1 gives me a negative 1x. And then 6 times 2x squared gives me a plus 12x squared. 6 times x gives me a plus 6x. 6 times negative 1 gives me a negative 6. So combine like terms here. There's only one term that has a 2x cubed, or an x cubed. And then I have an x squared plus 12x squared gets me a plus 13x squared. I have a negative 1x plus 6x gives me a positive 5x. And then I have only one constant here, which gives me a negative 6. And that is how you multiply binomial by times a trinomial. So hopefully one of these two methods makes sense to you. The FOIL method, or double distribute, or the box method here. And that's it. So have a great day. Bye-bye.